So we are going to discuss about the cut set matrix. So have you revised the tie set matrix, Prasanna? Prasanna, have you revised the topic tie set matrix?
Yes, sir.
Understood or any doubt?
Got it, sir.
Got it now. Okay. So like that, how we had created the cut set matrix in the same way, we will go for the how we created for the tie set matrix in the same way we'll go for the cut set matrix. So write the questions how we will create the develop the okay. You need to develop you need to develop a cut set matrix. Develop the cut set matrix for the network given below. So same network I am taking. Okay, capacitor is there and welcome. So this is your first branch, this is your second branch, this particular is your third branch, this particular is your fourth branch, this particular I am taking fifth branch, this I am taking sixth branch, this I am taking seventh branch, this I am taking eighth branch. So this is your network. Now write it down. Procedure for developing the cut set matrix. How we will develop the cut set matrix. Developing the cut set matrix. So how you will develop the cut set matrix? First you need to develop a graph. Okay, for anything you need to develop a graph. Okay, from given network. Second one, identify a tree. Identify a tree. Okay, so I told you about what is tree. Identify a tree from the graph. Okay, then you need to do identify the total number of basic cut set. And what is that basic cut set? I will tell you. Identify the total number of basic cut sets or a fundamental cut set. We can say basic cut sets or fundamental cut sets. Okay, or we can say F cut sets. F cut sets, any name. So this particular are different name: basic cut sets, fundamental cut sets, F cut sets. So how we will find the fundamental cut sets? Okay, so write it down. Basic cut sets means basic cut sets consist of only one twigs. And I told you what is twigs yesterday. And basic cut set direction, basic cut set direction is same as the twigs current directions. Twigs current direction. Okay, so yesterday I taught you what is twigs, the meaning of twigs. So in a tree we had seen na what is twigs, links and all, everything.
Yes, sir.
So can you tell me what is twigs? If you had revised the topic, I think you know.
The branch of tree.
The branches of trees. Okay. So the branch of tree is known as twigs. Okay. The branch of tree are called as a tree branches or twigs. Correct. Okay. Right. Yeah. So always remember this is the things, and always remember total number of basic cut sets will always be equal to total number of twigs. Total number of basic cut sets is equals to total number of twigs. Okay. Now for doing this, first write it down. Total. Let's do it. Person is coming. So what I am telling, total number of basic cut set, total number of basic cut sets will be equal to total number of twigs. And formula for total number of twigs is nothing but n minus 1. Okay. Now do the solution. So first draw the graph. Graph is very simple. For the network you need to draw the graph. So this was my network graph. So we had assumed in this 1, here we had assumed 2, branch 2, this branch 3, this was branch 4, this particular branch 5, this is branch 6, and this is branch 7 and branch 8. Okay, so first draw the tree. So if you will draw the tree, this is your tree. Okay, mark the solid line directions: 5, 8, 6 and 7. Mark the node also: A, B, C, D. Okay, and draw the dotted lines. That is known as links. Okay, now you have to draw the cut sets. So our first cut sets will be this. This is my first cut set, and whatever the what will be the directions, it will follow the node directions. So in this way. So how many cut sets we can create here? This. What will be the direction? It will follow the tree direction. See the tree branch directions, twigs direction. So this is my twigs branch of the tree 6. So it's following, and again this will be okay. What will the direction? It will follow the tree branch directions, and for this directions will be this. Okay, so this is what this particular solid lines is your twigs. So in twigs, at the end point, at the node point, you have to create these cut sets. Is it clear? How we are making this? Is this clear? First, draw the tree, make the dotted lines, and at nodes, this is my one twigs, this is my second twigs, this is my third twigs, this is my fourth twigs. I am creating the cut sets. And in cut sets, you need to follow the directions as a twigs directions. So at A, it's following the 5th branch. At B, it's following the 6th branch. And at C, it's following the 7th branch. And at D, it's following the 8th branch. Okay. Now you need to find the matrices. So how many nodes are there? 4 nodes. A, B, C, D. How many branches are there? 1, 2, 3, 4, 5, 6, 7, 8 branch was there. Okay. Okay guys. So this is your this is your which matrix? It is your cut set matrix. Now you need to draw the things. So at A, C at A. Okay, C at A. So first mark the directions. This was 1, this was 4th, this particular was 3, this was 2. Any other things? No. So at A, one branch is coming. Yeah, it's entering. So in entering we have taken positive. So I am taking positive value. Entering means positive and leaving means negative. Whatever the things you want to assume, it's up to you. So I am taking entering as a positive. So yeah, at A cut sets it entering. Okay. 2 is coming? No, 2 is not coming. 3 is coming? 3 is not coming. 4 is coming? 4 is not. 4 is coming. Entering only. So it will be 1. What about 5? 1. And rest 6, 7? It won't be there. 6, 7, 8, it won't be there. Just tell me about for B. B cut sets. Branch 1. See it. How it will be? B. The value for B.
-1.
But we will not give here -1. Why so? Can anyone tell me why so? See, here we have to see entering and leaving with respect to my branch, these directions. Okay, these directions. So for first case, see, we had assumed some directions in cut set directions like this. Okay, so what is the meaning? It's following my cut set directions. 1 is following my cut set directions. That's why it is entering. This is entering and it's following my cut set directions. 4 is following my cut set direction. 5th is following my cut set direction. That's why it is 1. C for B. B is following my cut set directions. 1 is following my cut set directions. One is following my cursor directions. If I'll go like this, it is following my cursor directions. One is, yeah, it is following my cursor directions. What about 2? 2 is following my cursor directions. It is following my cursor directions. Although it is leaving. Here you have to see with respect to cursor directions.
Exit direction.
Yeah, cursor directions you have to see. And what about sixth? Third, fourth is not there. Fifth is not there. Sixth is there. So sixth is following the cursor direction. Yeah,
Yes.
it's following the cursor direction. Now you understood. Okay, just tell me about C then. C.
Only 7 will be 1. Other 2 will be negative.
So other two, which two will be the negative?
3
Okay,
and 2.
3 and 2. Right, correct. And what about D?
8 will be positive
8 will be positive, and
and
3, 4 will be negative,
3 will be negative.
and
4 also will be negative.
fourth will be negative. Okay, so C. Yeah, and here in C seventh na came, add C seventh came. Okay. C. So guys, can you able to see anything in this part? In this particular part, can you able to see anything? Diagonal.
The one is a diagonal.
Diagonal. Okay. So here, this particular part, we are, and this particular part. So this particular part is known as U matrices. Okay. It's just a representation, like in a tie sets, we are getting the diagonal element earlier, but in a cut set we'll get it later. And this is your CL. This part is represented by CL, and your cut sets matrices will be CL is to U, augmented matrix. So overall it is known as cut set matrix, but up to this part it will be known as CL matrix, and this part will be known as U matrix. So it's just a representation. And why we are doing the cut sets? Cut sets are useful for what? We will get KCL. That's it. Okay. So note one point. So this is the procedure how you are finding for a cut set matrix and tie set matrix. So the tie set matrix and cut set matrix are linked to each other. The tie set matrix and the cut set matrix are linked to each other with the help of following formula. So there is a certain formula we can find it, our cut set matrix and tie set matrix. Okay, just wait for a minute. My pen is not working. Yeah, it's working. So the tie set matrix and cut set matrix are linked to each other. Okay, with the help of following formula. What is the formula? This is my B representations we had seen yesterday, U BT, and C representations it's CL is to U. So BT is what? BT is nothing but it is minus Cl transpose, and Cl is what? Cl is nothing but it is minus Bt transpose. So if you are getting the Bt matrices, you can find your Cl matrices, and if you are getting the Cl matrices, you can find the Bt matrices. So it's a transpose and all. I hope you know transpose. I taught you, and we'll see in a maths x y z l m n o p q. If we have a matrix, so A transpose will be,
Change the rows into columns and columns
yeah,
into rows.
so XLO, Y, M, P, and Z and Q. And you have to take the minus side. So if you have a BT matrices, so you will get the CL matrices, and if you have a CL matrices, you will get the BT matrices. Okay. Okay. The cut set and the tie set matrix are not unique for a particular graph. Write some important points. It's a means like they are asking questions from these points. The cut set matrix and tie set matrix are not unique. You have to see this chapter, means graph theory. You don't have to focus too much before the examination. Just look over this chapter, okay? Just look over these points and all. The cut set matrix and the tie set matrix are not unique for particular graph. This point just look over while you are going for the examination. The total number of possible cut set or tie set matrix will be equal to n to the power n minus 2. N is your node. And write the rank of a cut set matrix will be equal to, we will see the what is rank in maths. Till for now, just write it down. Rank is a very depth. It's require a very depth knowledge. What is the meaning of a rank? Every matrices will have a ranks. Okay, so we'll see these things in maths. For now, it's write it down. The rank of the cut set matrix will be equal to the total number of twigs, that was n minus 1. And the rank of the tie set matrix, the rank of the tie set matrix will be equal to the total number of links, that was B minus n minus 1. And the rank of incident matrix, the rank means actually how many independent equations you have in a matrix. Okay, we'll see these things in maths. The rank of the incident matrix is equals to n minus 1. The rank of incident matrix is equals to n minus 1. Okay. Matrix is equals to n minus 1. Now I will give you one proof. Last proof. Yesterday Cl is equals to minus.
So once please show the previous slide. Yeah, okay, so continue.
See, yesterday we got the BT value. BT value we got yesterday. That was, just check it from your notes. It was minus 1, 0, 0, minus 1, minus 1, minus 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. So this was the BT value, means your Tyset value, half value you are getting like this. And now you need to find the CL value. How you will do it? Transpose it. If you transpose it, what you will get? Minus 1,
0, 0, minus 1.
0, 0, minus 1,
Minus,
minus 1,
minus 1, minus 1, 0, 0.
0, 0,
0, double 1, 0.
0, double 1, 0, 0,
Double
0,
0, double 1.
double 1. And you have to multiply
Take the
now.
minus of the matrix.
Yeah. So 1, 1, 0, 0, 0, 1, minus 1, 0, 0, 0, minus 1, minus 1, 1, 0, 0, minus 1. So you are getting your CL matrix. This part done. Match the answer with this. See it. We are getting 1, 1, 1, minus 1, minus 1, minus 1, minus 1. Okay. 1, 1, 1, minus 1, minus 1, minus 1, minus 1. Same result you will get. Okay. So this was the story of graph theory. Graph theory is now over. Okay. So these things you have to, for now also you just have to revise 1, 2, 3 times. Just read it, and for examination you just look over these things. Okay. Before the examination, just read these things. Okay. Because it's a very theoretical chapter, and you need to know everything like n minus 1, b minus n minus 1, what is 2x, what is links. They are asking a statement questions from this particular chapter. Okay. They will not ask you like a very big questions like this. Find the cut set matrix, find the tie set matrix. They can give you one cut set matrix part like this, and they will ask you what is the tie set matrix. So you should know this formula.
So do we have the question in every year?
No. For a graph theory, it's like they are asking a question from, like it's there is a gap of 4 years, 5 years. It's like that. Okay.
Okay.
So that's why it's not a very much important chapter, but it's a part of our syllabus. That's why we covered this chapter. Okay, now write it down. The next topic, that is filter. So there is a, how many kinds of filters you know? How many kinds of filters are there?
Low pass, band pass, high pass,
Low pass,
stop band,
stop band.
band pass.
Okay. Okay. See. Uh, what is the use of filter?
To remove any unwanted ripples from the signal.
Okay. Suppose you having a frequencies of like this. This is your frequency response. This I am taking x of f, and this I am taking f. So from 0 to infinite frequency range, you are getting a curve like this, but you want this particular part only. From 0 to, suppose you want 500 hertz only. So what you will do, then you will get this particular kind of a graph. You will use low pass filter, 0 to, whose bandwidth will be 0 to 500 hertz. Okay. And you will do multiplications with this, means you will cascade this signal with this. So the result will be multiplied part. You will get this part will get eliminated. All the high frequency will get eliminated. So you will get the result like this. Okay, like this, 0 to 500 hertz. Now if you want to get the signal of a band pass filter, means suppose you want to get the filter response, like if you want to generate the signal from some, suppose some 1000 hertz to infinite, so for that you will use high pass filter, from where your high frequency will get passed. Okay, so this was the, and there is a some band pass filter. Suppose you want to make one filter which will pass a band frequencies from this frequency range, means suppose you want to get the signal from 500 to 1000 hertz, this is your band pass filter, and the result will be like this, you will get something like this. And suppose you want to reject the band frequency, means reject, if you want to reject this part, so result will be like this, it will be like this part will get rejected. So to do these things we are designing the filter. Okay, how so, how you will design the filter?
By using capacitors,
By using capacitor. So there is a, okay,
resistor also.
but resistor is also there. And if you want to make the low pass filter, how you will make the low pass filter?
Are connected with C in parallel.
Are connected with C in parallel. Is it so? Okay, first write it down about filter. I will tell you.
I think in series.
Okay, write it down. First write it down. I will tell you. Don't worry. Filter can be broadly classified as active filter and passive filter. Active filter and passive filter. So what is the meaning of an active filter? Active filter is a mode of, active filter is it's not it's is active filter is made of operational amplifier, op amp, and capacitor, resistor, and inactive capacitor, some resistor will also be there, and in active filter we can increase the gain of the signal, and in active filter we can increase the gain of the signal. Gain means, okay, gain means how much you had amplified the signal in a very simple way. Okay, what about the passive filter? Passive filter is passive filter. So passive filter is made of series and parallel combinations of inductor, capacitor. Passive filter is made of series and parallel section of inductor and capacitor. Okay, and in a passive filter we cannot increase gain of the signal. We can not increase gain of the signal. So remember this particular point, in which filter we can increase the gain of the signal and in which filter we cannot increase the gain of the signal. So in passive filter we cannot increase the gain of the signal. Okay, we cannot increase the gain of the signal in which filter? In passive filter. Okay, now according to the frequency are classified in the following categories. Low frequency is there, high frequency is there. So suppose you want to create a low pass filter. Low pass filter. So how you will create the low pass filter? You will connect one resistor. So this is your, I am taking it in the Laplace transform. So I am taking this as a Vi of S, R and C, and output you will get as V naught of S. If you will convert this in the Laplace transform, you will get 1 upon Cs. We are assuming the initial condition is 0. Okay, now you want to get the value of a V naught. So V naught value of V naught of S will be, apply the voltage divider rule, Vi of S into 1 upon Cs divided by R plus 1 by Cs. Okay, so what you will get? V naught of S is equals to Vi into 1 divided by RCS plus 1. Right. Bring this in this side. V naught of S divided by Vi of S. So this is known as a transfer function. Output by input in a Laplace transform, it is known as a transfer function. And what you are getting? 1 divided by RCS plus 1. Okay. Basically S is what? Your J omega. Okay. Okay. Now tell me, so transfer function you are getting as a 1 divided by RCS plus 1. Okay, so just tell me what will happen if your S value is 0. If your S value will be 0, you will get V naught of S is equals to Vi of S, right? When the frequency means at low frequency you are getting this, and if S is equals to infinite, what will happen? It will become 0.
0.
So case 1, at S is equals to 0, you are getting R and this particular plus minus Vi of S, and current will become 0, so that your Vi of S is coming same as V naught of S. But when S is equals to infinite, what it's happening? It's stopping. It's getting stopped. It's getting short circuited, and you are getting plus minus Vi of S here. So it's stopping. So what you understood from here? At low frequency it will pass the signal. So at low frequency means my S is equals to 0. We are passing the signal. Signal is getting passed. But at S is equals to infinite, this transfer function is becoming 0. So it will stop the signal. So you will get a filter like this. It will pass the signal up to some lowest frequency, cutoff frequency.
So that S is equal to infinity, right? You have written 0.
Yeah, as we had substituted two different value. S is equals to 0, we are getting like this, and S is equals to, this is your S is equals to infinite. Yeah. Okay, and this is for S is equals to 0. So at S is equals to infinite, we are getting a transfer function. Transfer function is getting 0. If you put 1 by infinite plus 1, it will become infinite only, and 1 upon infinite will be 0. So this is then our signal will not get passed. So that's why it's working as a low pass filter, right? Is this clear? Is this clear how it is working?
Yes, sir.
Now if you will go for the high pass filter, second is your high pass filter. So for high pass filter, capacitor position will get or resistor position will get interchanged. This will be Vi of S and this will be your plus minus V naught of S. This is your R, right in the Laplace domain only, 1 by Cs. So what will be the V naught of S? V naught of S will be Vi of S into R divided by R plus 1 by Cs. So Vi of S into RCS divided by RCS plus 1 divided by RCS plus 1. RCS plus 1. Now tell me at what frequency? If you are putting 0, what it's happening? At S is equals to 0, write the transfer function RCS divided by RCS plus 1. So what it's happening? At S is equals to 0, transfer function is becoming 0. That means it will not pass the signal at 0 frequency, right? It will not pass the signal at 0 frequency. But at S is equals to infinite, if you are putting, you are getting what? Infinite upon infinite, right?
Yes, sir.
Infinite upon infinite. So for this we'll use L'Hospital rules. L'Hospital rules. We'll study this in maths also. For means the conditions when we'll get infinite upon infinite, we have to differentiate upside and we have to differentiate downside. Okay, if you will differentiate upside, the L'Hospital rules means, see what we are doing, transfer function is RCS divided by RCS plus 1 and our limit is, what we are putting the limit? Infinite. So when you are putting the infinite value, you are getting infinite by infinite. So when this condition will happen, then you have to do limit is infinite only, differentiate this, first numerator, differentiate numerator with respect to S. So dRCS divided by ds and differentiate numerator with respect to S. So d divided by ds into RCS plus 1. So when you will do the differentiation, what you will get? RC upside, and what you will get? RC only, and one differentiation is 0, so it's getting cancelled out. So you are getting some particular value. So that means at high frequency the signal will pass, right? The high frequency the signal will pass. So means the case is like at S is equals to 0, at S is equals to 0, signal is getting stopped, means this is getting stopped, it's not passing this current. But at S is equals to infinite, what is happening? Your voltage is getting crossed, so it's passing. So what particular graph you are getting? Some cutoff frequency up to infinite. See also, I will tell you in a very easy way. You have a circuit like this, RC, positive, negative, Vi of S, and this is your plus minus V naught of S. So capacitor can be written as 1 upon Cs, and this is your R. S means j omega. So if the omega value will be 0, if the omega value will be the 0, then this circuit will get will get, if you'll put the 0, what resistance you are getting, reactance I mean, it will get, if you'll put 0 it will get 1 upon 0. If you are putting, what you are getting, infinite. Infinite means it is getting open, this value is getting open circuited. So whatever the voltage was there, it's passing that voltage here, means current is passing from here to here. So at 0 frequency it is working, but when you will do x is equals to, means when you will substitute s is equals to 0 or infinite, if you will substitute s is equals to infinite, so you are getting what, you are getting 0, means this will become short circuited, means plus minus vi of s, and this is your plus minus v naught of s. So whatever, all the current is getting grounded here, it's coming grounded here, and you are getting a 0 voltage, means there is a nothing you are getting at high frequency. Now if you will change the positions of the capacitor like this, if you will change the position of the capacitor like this is your R, this is your plus minus vi of s, this is your plus minus v naught of s, and you are writing 1 upon cs, and here R. So at s is equals to 0, what will happen, it will get open circuited, right? At s is equals to 0, we will get the huge value. So what will happen, the capacitor circuit will get open circuited, the capacitor circuit will get open circuited. So what will be the figure, what will the figure, it will get open circuited, plus minus vi of s. So no current will able to flow because it's getting open circuited. So our voltage we are getting 0 because there is a no current. So 0 current, 0 into this particular resistance, we are getting the voltage as a 0. But when s is equals to infinite, what will happen, it will become short circuited. This is your plus minus vi of s. So whatever the voltage is present, it's come across this v naught of s. So at high frequency it's following, it's passing the current, at high frequency it's passing the current. So that's why we are getting this kind of a filter. Understood guys, understood, or still any doubt?
Yes, sir. Got
it. Okay. Now write the story about okay, I will tell you one thing. So this is your low pass filter, this is your high pass filter. We are talking about which filter, passive filter, passive filter. Okay, so low pass filter transfer function, what we got, 1 upon 1 plus RC.
yes.
So this RC is known as tau, time constant. So 1 plus tau s. And in high pass filter, what we got? In a high pass filter, what we got? RCS divided by 1 plus RCS. So how we can write? It's RC is known as time constant, so tau s divided by 1 plus tau s. Okay. Write the next heading, band pass filter. So how can we make our band pass filter? Okay. So a band pass filter can be obtained by connecting a low pass filter and high pass filter. Low pass filter and high pass filter in cascade. In cascade, where the cutoff frequency of low pass filter must be greater than the cutoff frequency of high pass filter. Where the cutoff frequency of low pass filter must be greater than cutoff frequency of high pass filter. Frequency of high pass filter. Okay, so what the results you will get? See, this is your low pass filter. Okay, and you are doing cascading with, and suppose your cutoff frequency is 100 hertz. Okay, so your high pass frequency cutoff frequency should be greater than 100 hertz. So I am assuming this as a, yeah, so I am getting this particular as a 200 hertz. So this will become, I think, wait, just wait. A band pass filter can be obtained by connecting a low pass filter and high pass filter in cascading, where the cutoff frequency of low pass filter, oh sorry, this will be, if you will do this thing, so it will become band reject filter. I am really sorry. So suppose I am giving, this is my low pass filter. Okay, this is my low pass filter, this is my high pass filter. So if I am taking this as a 200 hertz and if I am taking this as a 100 hertz cutoff frequency high pass filter, so what will be the results? We'll get the combined result. What we'll get? 100 hertz to 200 hertz. It will pass the signal. Okay, so this is nothing but this is RC network, and this is nothing but this is CR network, some other value. So if anyone asks you construct the diagram, then how you will construct it? This is my R1 value, this is my C1 value, this is my C2 value, and this is my R2 value. So this is low pass filter, and this is your high pass filter. Okay, and for band pass filter means overall it is a band pass filter. Band pass filter, where the cutoff frequencies of low pass filter must be greater than the cutoff frequency of high pass filter. FC of this must be greater than FC of this. Is this clear to everyone, or any doubt? Rosanna, is there any doubt, or is this clear?
No, sir.
So now if you want to make the band stop filter or band elimination filter, same thing only. Band elimination filter or rejection of band stop filter. So what you will do, in this you have to connect low pass filter and high pass filter parallelly, where cutoff frequency of the low pass filter must be less than cutoff frequency of high pass filter. Okay. So what you are doing, you are connecting parallelly. This is your low pass filter and this is your high pass filter. You are connecting parallelly. You are providing one input, this input, and from this you are getting the output like this. You will get, means particular this branch will get run off because of this low pass. So this is my low pass filter and this is my high pass filter. So suppose the cutoff frequency is 100 hertz, the cutoff frequency of this should be greater than 100 hertz. So I am taking 200 hertz. So between 100 to 200 my frequency will get chopped, my response will get chopped. Okay. And there is another one filter that is known as notch filter. Notch filter. So notch filter is nothing but it's like this, you will get. Let's see. So notch filter is like a band reject filter only, but it will give you a narrow result. So it's a type of a band reject filter only, band stop filter. And that was the fourth one. And the fifth one is all pass filter, which will allow every frequency to pass. All pass filter. All pass filter. So all pass filter will allow every frequency. In all pass filter, the poles and zero. In all pass filters, the poles and zeros lies symmetrically with respect to imaginary axis, where poles lie in the left network and zeros lies in the right half. Where poles lie in the left half and zeros lie in the right half. So post zeros concept I will teach you in control system, but for now draw this graph. So suppose you are getting see, poles and zero is nothing but you are getting s plus a divided by s plus b. So this particular a minus a will be your zeros, numerator part, and minus b will be your pole, minus b. So pole representation, pole can be represented by cross and zeros can be represented by 0. So 0 is the negative root of the numerator, and poles are the transfer function. This is your transfer function. So if you are getting any transfer function like this, So negative zeros are the roots of the numerator, and poles are the roots of the denominator of the transfer function. Okay, roots, uh, poles are denoted by cross and zeros are denoted by dot. Okay, so in all pass filter, what they are saying, in all pass filter, poles and zeros lie symmetrically. Okay, lie symmetrically with respect to imaginary axis. So this is your imaginary axis. This particular is your imaginary axis. Plus j minus j. So whatever the poles you are getting, suppose you are getting a poles minus a, you are getting one pole as a minus a. So your zero should be the mirror image of this. So you will get 0 at a. Okay, if you are getting a poles particularly at this axis, so 0 should also be here. 0 should also be here. Suppose you are getting a poles at this axis, so 0 should also be present at this axis. So all the poles, this was your poles only, you will get at the same sides zeros, symmetrical part. So this was, and one simple example, like you are getting one minus a here, then in all pass filter a should come that side. Okay, guys, understood up to this? Prasanna?
Yes, sir, clear.
It's clear. Now write it down, first order and second order system. See, so there is a first order and there is a second order. So first order low pass filter is 1 plus tau s. Second order low pass filter will be p divided by s square plus as plus b. So this is your second order low pass filter. First order high pass filter is tau s divided by 1 plus tau s. Low pass filter, high pass filter. And the second order will be ps square divided by s square as plus b. I am giving you the transfer function. ps square divided by s square plus as. You can cross verify by putting zeros and infinity. As plus b. So this is the second order high pass filter. And for band pass filter you will get a characteristic equations like this. Don't try to memorize this particular formula. Just substitute the value of s is equals to 0, s is equals to infinite, and according to that just say that is it low pass filter, band pass filter, or band reject filter. S square plus as plus b. So this is my band pass filter. And if you want to draw for a all pass filter, you will get an equation like this: s square minus as plus b divided by s square plus as will come plus b. So when you are getting the upside things and downside things are same, but the middle sign is getting changed. This kind of a transfer function is known as all pass transfer function, all pass filter. All pass filter can also be, you can say 1 minus tau s divided by downside. If here it is minus, so it will come plus tau s. A band pass filter, you can write band pass filter will be ps divided by, second order band pass filter will be ps divided by s square plus as plus b. This is the second order band pass filter. So in examinations they will ask you questions like this. They can give you a circuit. You need to identify. Question is identify the type of filter shown in the network given below. So your network is like this. Okay, and you need to find the what kind of a filter it should be. You don't need to draw anything. See, it's very simple. This will be LS, this will be R1, this will be R2, this will be R3, and this will be 1 upon CS. So at S, if you will put at S is equals to 0, how you will get the circuit? It will get short circuited. You will get R2, you will get R1, and you will get R3, and this will get open circuited. So this is your Vi part and this is your V0 part. So guys, so these particular things will get solved, means we'll get some particular resistance like this. So operation is going on, means we are getting the frequency at low value, at low frequency. But when you will put S is equals to infinite, what will happen? This will get open. This particular things will get open like this. And your capacitor will become infinite, it will become short circuit like this. So what is the meaning of this? So at high frequency, if you solve this signal, you are getting like this, and it will deviate from here only. It won't go that side because it's having a short circuit path here. So there no current will flow, means your voltage will be 0 only. So you are getting the frequency at low value, 0 to some cutoff frequency. At high frequency you will not get the value. So this is what? This is nothing but this is just a low pass filter. Okay, now the second question is, you need to find the low pass filter or a band pass filter. The question is like this: you have a inductor, you have a capacitor, here you have a inductor, and here you have a capacitor. So, and this is your question. So you need to find, is it low pass filter or high pass filter? This is my plus minus V naught of S. This is my plus minus Vi of S. So what we will do, we'll just do the same thing only. Put S is equals to 0 and check it whether the frequency will come or not, whether the current will come or not. Okay, so if you will put S is equals to 0, this is Ls, this is 1 by Cs, this is Ls, this is 1 by Cs. So what circuit you will get? S is equals to 0, so it will short circuit. This particular will be short. And here it will be open circuited. Capacitor will be open circuited. And here it will be short circuited. And here it will get open circuited. This is your part. So current is passing plus minus Vi of S and plus minus V naught of S. Means we are getting a something result like this. Oh, Vi of S is equals to V naught of S. So it's working for a low pass filter. But what will happen when S is equals to infinite? It will get open circuit, it will get short circuit, it will get infinite means open circuit, and it will get short circuit. So you are getting like this, same circuit. plus minus vi of s plus minus v naught of s. Same things you are getting. So in this also current is passing, means at low frequency also the current is passing, and high frequency also the current is passing. So it's happen in which pass filter? Either it will be a all pass filter or it will be a band reject filter, because at low value also my frequency is passing, and at high value also my frequency is passing. So either it could be a band pass filter which will allow all the frequency to pass, and either it will be a band reject filter which will limit certain bands. Okay, so it is actually a band elimination filter. By this way we can directly say. Okay, now question number 3. If you have a filter like this, series that side, and this particular this side. Okay, put s is equals to 0, what you will get? It will get open, it will get open, again open, resistor is there, capacitor will get open. So current will able to flow, vi of s, and this is your plus minus v naught of s. No, because this is open, so there will be a no flow, so it will be v naught of s will be 0. And at s is equals to infinite, what it's happening? At infinite it will become short circuited. Okay, it's becoming short circuited. At infinite this is becoming a short circuit. So if it is a short circuited, and short circuited is parallel with resistor, so whole it's becoming like this, short circuited. So there is a no use of this particular resistor then, because it is getting short circuited. So all the current will be bypassed like this. Okay, so what is happening? What we are getting? V naught value 0 at high frequency. So what is the filter? It's representing a low pass filter, because no, it is not representing a low pass filter also, sorry, because at 0 frequency also there is a no, v naught is 0, and at infinite frequency also v naught is 0. That means it is a band pass filter, not band reject, band pass filter, because at initial frequency also we are getting a 0, and at at high frequency we are also getting 0. That means it is a band pass filter. Guys, getting or not these things? Okay. So it's a band pass filter. Now a last question. So you have a filter like this. This is your homework problem. It's crossover. Okay, so okay, let me solve this. So now this is question of for this you have to comment, is this is my vi, of s, and this is my v naught of s. Okay, so you have to comment whether it will be a low pass filter or high pass filter. So put the value of s is equals to 0. If we will put the value of s is equals to 0, inductor will get shorted, capacitor will get open, so it is shorted, but capacitor will get open. In this also it will shorted, inductor will be shorted, and it will capacitor will be open, and this particular same thing, capacitor inductor will be shorted, capacitor will be open. So this is your plus minus vi of s value, and this is your plus minus v naught of s value. So it's what, it's nothing, it's like this only, vi of s plus minus v naught of s. So my at zero frequency I am getting the value, means thus v naught of s is equals to vi of s. But at s is equals to infinity, what will happen? At s is equals to infinity, what will happen? So at s is equals to infinity, inductor will get open, but capacitor will get shorted. Inductor will get open, but the capacitor will get shorted. Here in this, inductor will get open, but the capacitor will get shorted. Inductor will get open, but the capacitor will get shorted. We are getting something like this. So this is nothing but this is the same representation. We are getting like this only. We follow this path. Okay, this is open, so it's a negligible thing. We are getting this particular part, plus minus vi of s plus minus v naught of s, means at high frequency also we are getting the voltage, and low frequency also we are getting the voltage. That means what? That means it is band reject filter only. Means at low frequency also it's getting value, and high frequency also we are getting the value. So it will be a band reject filter. It will be a band reject filter. Or it could be a band reject filter also, or it could be a all pass filter also. Okay, so it could be a band reject filter, and it could be a all pass filter. Okay, so for this you need to solve that transfer function, and you have to see that your poles and zeros conversion is coming or not, that you are getting the equal parts this side also. And you can do one thing, yeah, from this way you can solve this kind of a question. So you need to practice, then only you will understand how to say it's a band pass filter, all pass filter, band reject filter. Okay, so this was the story of filters. We'll see the filters in signal and system also. Filters will come in signal system also. These things, it will come in signal and system also. Okay, now the last topic of the network is magnetic circuit. Magnetic circuits, last part of the network. So guys, suppose you have a turns here, and you have a turns in this loop. This is your AC supply. positive, and from this you are getting one current. This is your N1 turns, this particular is your N2 turns. So because of this N1 turns, you will develop you will develop flux phi 1. Okay, and because of this N2 turns, you will develop another flux, that is phi 1 2. This is known as, and suppose it is resistor, it's connected. Okay, due to the influence of this particular circuit you are getting this flux, and this is because of this particular circuit you are getting this flux. Okay, so there is a overall flux in overall flux in a circuit 1 is phi 1. Okay, so phi 1, write this as a phi 1 1. Okay, so phi 1 1 because of N1 turns, and phi 1 2 because of N2 turns. Okay, so in this, what is your phi 1 1? Phi 1 1 is known as leakage flux. Leakage flux. And phi 1 2 is known as a useful flux for magnetizing. Useful flux. Useful flux or magnetizing flux. Flux is nothing but, yeah. So there is a concept of mutual flux, magnetic flux, and see, first, if you want to get the, means if you want to get the voltage potential in this particular loop, so your E2 will be what? I'm telling because means I'm assuming some current is flowing in this, some particular I2 current is flowing in this, I'm assuming. Or not to take I2 current, we know the relationship between EMF and flux. In the first class itself I told you E2 is N2 into d phi 1 2 divided by dt. Phi 1 2 due to the useful flux, whatever the useful flux is created by the loop 1 we are getting, and we can write it like this: E2 is equals to N2 d phi 1 2 di1 into di1 into dt. I1 and I1 I had multiplied, so this N2 into d phi 1 2 N2 into d phi 1 2 can be represented as M12 into di1 by dt. Okay, so what formula you will get? M12 is nothing but N2 into di1 by dt. Oh, sorry. M12 we are getting N2 into d phi 1 2 by di1. Okay, and what is your E1 current? E1 current is nothing but, E1 is due to the coil of N1 only. E1 is equals to N1 into yeah. So in the same way, means what we are getting, just wait, my marker is not working. In the same way, E2 is N2 into d512 by dt na. In the same way, you will get E1 is equals to N1 into d521 by dt, and M21 will come N1 into d521 by di2, and E1 we can write like this, M21 into di2 by dt. Okay, so this I am assuming is as a equation 1, this I am assuming it as a equation 2, and 512 is nothing but k1 into 5 1, and 521 is nothing but k2 into 5 2. It's equation 3 and this is equation 4. So if you'll multiplied equation 1 into equation 2, what we'll get? M12 into M21, what will get? N2 into coil loops of 2 into d512 divided by di1 into N1 into d521 divided by di2. Okay, and here you have to substitute 3 and 4. So 3 and 4 was 512 is k1 5 1 and 521 is k2 5 2. So if you will substitute, what you will get? N1 into N2 into d k1 512, so 5 1 divided by di1 into d into k2 into 5 2 divided by di2. Okay, so you are getting k1 k2 n1 d5 1 by di1 into n2 into d5 2 by di2. So I hope you remember the formula of L1, leakage inductance, what we had these things we had discussed in the class of beginning classes. K1 K2 N1 into d5 1 by di1 is flux, means inductance value of N1, and this is your L2 value. Okay, so you are getting K1 into K2 into L1 into L2, M12 into M21 formula. Okay, and if and this M12 and M21 will be equal, so M square will be K1 and K2 value will be equal K square into L1 L2. So this M value what you are getting? K root under L1 into L2. So from these equations, like we are getting, so K is nothing but K is your coefficient of coupling, coefficient of coupling, and K is nothing but useful flux divided by total flux, useful flux divided by total flux, and the value of a K will lie between 0 to 1. Okay, now I'll tell you in a very detail. Don't get nervous because these things are not too much complicated. See what the things is happening now. You have a AC supply and this is a number of turns. I am saying this is my N1 turns. So if I am having the AC supply and if some current I1 is flowing and this current is AC, so it is change in current. So Faraday's law, what the Faraday say, if any change in current will flow from any loop, means any coil, So there will be what will develop? A magnetism will develop. Magnetism will develop. So this can be represented by how we are representing this. We are representing this magnetisms. This magnetism is representing by how we are representing it's by we are representing it by flux. Okay, flux. So this is your flux, means you are getting a these things we are representing it's phi 1. Okay, this magnetisms we are getting. And suppose we are having a coil nearer to this. This is my n1 turns, this particular is my n2 turns. So, and suppose this particular is your closed circuit. Okay, so because of this magnet because of this flux na, there will be a induced current will develop, I2 current will develop. Okay, I2 current will develop, and because of this I2 current, there will be another flux will develop. So that's why we are saying there is a two kinds of a flux. So flux, one is your phi 11 and another is your linking to the another coil. Linking to the another coil is represented by phi 12.
So this is known as mutual inductance, right?
Yeah, mutual inductance, particularly, exactly. So mutually inductance. So that's what I did it. If I want to find the current because of this N2, this particular coil, so E2, my EMF will generate. E2 is equals to N2 into D phi 12 because of this flux linking to another coil. So I am getting E2 is equals to N2 into D phi 12 divided by dt, and this can be represented by phi 12 into di1 into di1 by dt. So this particular name we had given as a mutual inductance, M12. Okay, so E2 is M12 into di1 by dt. Okay, M12 is nothing but N2 into d phi 12 by di1. Okay, and phi 12 is k1 phi 1 and phi 21 is k2 phi 2. So same thing means for E1 like how you are getting E2, the similar way you will get another E1, that will be n1 into d phi 21 by dt. M21 will be n1 into d phi 21 by di2, and when you will substitute it, you will get it like this. So when you will multiply equation 1 and equation 2, you are getting M12 into M21, put the value, N1 into N2, put the value of a phi 12. Phi 12 is nothing but K1 into phi 1, and phi 21 is nothing but K2 into phi 2. Okay, bring this constant outside, you are getting K1 into K2, and this formula we know. There was a one formula, N1 into D phi 1 by di1. It is representing inductance. N2 into d phi 2 by di2, it is nothing but it is your inductance, another inductance. Okay, and M12 and M21 will be equal. Mutual inductance of 1 to 2 and 2 to 1 is equal, and your K1 will be equal to K2. So we are putting the value. That's why we are making it as a M square, and K1 into K2 is your K square, and L1 L2. So we are getting a coupling coefficient. M is equals to K into root under L1 L2. So K is your coupling coefficient. So coupling coefficient is nothing but useful flux divided by total flux, and the value of a K will lie between 0 to 1. Okay, so now assume how the transformer is working. So see, again these things will come in machines. but I am giving you a basic idea. So this is your plus. So you are developing some EMF. So I am writing E1. Okay. And here also you having a turns. This is your load. Okay. This particular is your load. Okay. Now see, current direction is this. This is your current direction. Current is moving like this, this. So if current is moving like this, how will be the right hand thumb? Use the right hand thumb rule. Right hand thumb rule. This is your thumb. This particular you are using. So this is your thumb. Right, and if it is showing, this is your curl, and this is your thumb. If my curl is showing current directions, then thumb will represent flux. And if my thumb is representing current directions, then my curl will show the flux. So here I am using my curl, my all the four fingers as a curl. So they are representing what? They are representing the current. So the flux directions will be where? Flux directions will be this is your flux directions. Okay. So flux directions will be in this in these directions it will come. Okay, this is my thumb. I am putting my thumb like this. This is my thumb. So it's showing current. So the flux is coming like this. So yeah. So I am writing this particular flux as a phi 12. Okay. Now just say to me, use the same constant. Use again the same concept and tell me if my phi 12, if my curl directions, if my flux directions is in this, then curl will represent, if I am using this as a flux, then this will represent current direction. Current directions, right? Current directions. So guys, but there is a concept of a Lenz law. You know what is Lenz law? What is Lenz law, you know? Anyone? Anyone know the Lenz law? See. Always remember, whenever you are drawing one flux na, you have to draw another flux. Another flux you have to draw. Another flux you have to draw. And this flux direction is this direction. And the another flux what you are drawing now, you have to change the directions of that. Okay, you have to change the directions of that particular flux. So Lane's law, what the Lane's law is saying, whatever the flux you are getting in the another, in the secondary part, the opposite flux will create. Opposite flux will create. So that's what we are representing this flux as a phi 2 1. Phi 2 1. Opposite flux means you have a transformer like this. You are getting one flux in this particular direction. Then because of this flux and there is a number of turns, the opposite flux will create. And from that opposite flux you have to say what will be the current of this particular loop. Now apply. You have to see this black one. Apply the right hand thumb rule. So you have a flux directions upside, right. So current will be this only. Prasanna, getting or not, or getting confused? Just tell me.
Got it, sir. The magnetic field which is created by the first magnetic field, it will be opposite to the first one, right?
Yeah, exactly. So we are getting a curl like this, this, this. So this curl is going, so this is coming, and this. Okay. So it's going like this, it's going like this, it's going like this, it's going like this, it's going like this. Okay. So from positive, your current is leaving, and in negative, current is entering. So this is your E2. Okay. In this it is becoming a voltage source. In this it's absorbing the things. Okay. In this it's becoming a E2. So that's why that is my positive. Okay. Now, so this concept I think it's clear. Now see, this is your inductor, this is your I1, this is your I2. So if I1, if I am giving this as a dot, so if in a primary the current is entering in a dot, if the current is entering in a dot, okay, this is, assume this particular is also a dot. I will tell you. Okay, this is L2 and this is L1. Okay. So there is a lots of problem you will get. First write like this. One circuit, one could be like this circuit, another circuit could be like this. Representation means I1 is here, you are getting particular dot this side and particular dot this side. One, it is leaving. Okay, this is my dot, this is my L1, this is my L2. And the second concept, third one, if I am giving this dot this side, L1 this side, this is my I1, this is my I2. So mutual inductance will be from this dot to this dot. So, okay. So how you will solve this? So see, it's nothing, it's very easy. Do like this. From dot it's coming, give the positive sign, give the negative sign, dot, its current is going, give the positive sign here, give the negative sign here. Okay, now you need to change the circuit in a dependent and independent term. So make it as a L1, and this particular positive negative M di1 by dt. Okay, I1 current, equivalent representation is this L2 positive negative M into d dt. Okay, this will be d I2 and this will be your di1. Okay, in the first loop, whatever you are making a dependent source, so this will become M di2 by dt and this will become M di1 by dt. Okay, you need to bring like this, positive negative, and you need to bring this particular like this. Okay, guys, you are getting or not what I am saying? Just wait for a minute. Where is that? Yeah. Okay, so now there is a convention. See, so what we will do in this part, if you want to solve this particular circuit, so first what you need to do, make it like this, make it like this. This is your I1. So dot is here. Dot is here means it will be positive. It is negative. Okay. Now it is leaving from that dot. It is, the current is leaving from the dot. So leaving from the dot, where the current will come? Here the current will come. So you will give positive here, negative here. Okay, positive here, negative here. I2 is here only. Okay, see the current directions. Here current is coming towards this. That's why I am giving a positive here only and negative here. Here the current is coming, so positive, negative here only. Here the current was coming, so positive here, negative here. Here the current is leaving. So where the current will come? Here. So positive will be here and negative will be here. So you have to do like this. And now what you will do? You will do the same thing. You will make this as a L1. This is your I1 current. You will make this particular thing, this particular directions you have to bring like this. So negative, positive, M di2 by dt. And this particular is your L2, and positive negative you have to bring like this. So it will be positive negative M di1 by dt. Prasanna, see what will the scenario of this then? Just tell me. Here what will be the positive or negative? Prasanna, I am asking to you.
Positive.
Okay, positive. And this will be negative. And where it will be a positive and where will be it negative in this particular third one, in I2 part? In I2 part, where will be the positive and where will be the negative? Tell me. See, what is the scenario, actually? What is the meaning of dot? Dot means in this dot current is entering, and in this dot current will leave from this particular point. Leave from this particular point. Okay. So see, first see, in this particular dot, our current is entering, right? Our current is entering in this dot. So what is the meaning of this? In this dot current should leave, but see the directions, they had given the current directions like this, I2 directions like this. So if it is going, leaving, and what I had shown you, when the current is leaving means that particular point is positive. That particular point is positive. So actually it will be positive only and it will be negative only. So we had given like this. This is my positive and this is my negative. In this case also, this is my dot. So in this dot my current is entering. What is the meaning of this? In this dot current should leave.
Leave.
Yeah, current should leave. So here the case is given same only. Your current is
Leaving.
leaving only. So if this is the scenario, then you have to give positive where the current is entering. Here the current is entering, but see here, this is opposite. It's following the opposite rule. Current is entering here, and current is leaving here. Current should leave here, but what is the current directions they had given? Opposite
Entering.
opposite directions they had given. Opposite directions they had given, right? They had given the,
So the main we have to consider is current direction, right, sir?
yes, the main you have to consider the current direction. So see, understand this particular bits because it's very important. If you will understand these things now, this question, because upper part is not that much important, these particular things, if you know how to convert these circuits in this circuit, then any question you will able to solve any question. So see, your I1 is entering in this particular dot, okay, and from this dot the current should leave, but what they had given the opposite directions of the current. Opposite directions of the current. So if they had given the opposite directions of the current, okay, and current is leaving from this terminal, so that's why we are taking it as a positive, because it's opposite directions. Here current will enter in this, and see in this is your dot part. So current is entering in this particular, entering into this particular terminal. So from where means current is entering into this particular terminal. Okay, it's going, so it will go and it will leave this particular terminal. So, and what is the current directions they had given? Same direction. So if my current is following the same direction, then it will be negative, and if my current is following the opposite direction according to our assumptions, so then it will be positive. Here also the same thing is happening. Current is entering, okay, they had given these directions. Current direction is this. So, and this is my dot, so from if it is entering in this side, so there it will leave this side, okay, it will leave this particular side. So it's following what? It's following same only. So in same case what will happen? We have to, where we are giving the negative and where we are giving the positive. In the same case, see,
In the same case, we give the positive.
No. In the opposite case, we are giving the positive at dot terminal. See, understand. This is your positive terminal and the current is entering in this terminal, if it is entering, so it should leave, and actual directions of the current they had given like this. So this is opposite. So in that opposite cases, we are making at our dot as a positive part, right? We are making dot as a positive part. Here what is happening, this is my dot, it is entering in dot terminal and it is leaving from the dot terminal. If it is leaving from the dot terminal, and the current directions they had given these directions only, so they all are same only. So here what we are making, negative.
Negative.
Yeah. And what is happening here, the current is entering into this terminal, and the current, and see, if it is like this, you have to see the dot part. Okay, you go to the dot part directly. If the current is entering in this terminal, okay, so current is entering, so current should leave from the dot terminal, right? And if it is upside, so let me correct. Okay, so current is coming in this direction, and it's leaving this directions. Okay, it is leaving this directions. Okay, so I think, just wait. So there is oh, it's 11:05. Okay, we'll see this things tomorrow. Okay, so means for now we'll continue the magnetic circuits tomorrow. A little bit portion is left, so this convention I will tell you tomorrow perfectly. Okay, so there is like a dot and cross convention, and one or two three questions is there for M1 to M21. We'll see it tomorrow. Okay, for now what you have to do, you guys just go leave these things for today. We'll see it tomorrow. Convention part means what is the positive and what is the negative part we are taking. So you just go through these derivations. Okay, this derivation, you just go through these derivations and try to solve by yourself how we are getting these derivations, and we'll see these things tomorrow. It will take hardly 20 minutes to complete this chapter, and we'll start the signal system from tomorrow. Okay, Prasanna?
Yes, sir.
Okay.